Let us take another question. 6 volt charged from a 6 volt battery, and here it is 2 microfarad, and it is 4 microfarad, and here it is 2 microfarad, and here it is 6 volt. Again 6 volt. So see, charge concept is same as current concept. So we take the charge from here. This charge also will be same. If this charge is Q, this charge is Q. And since it is law of conservation, according to the law of conservation of charge, this is here, this is charge Q, and this will come 2Q. 2Q. Okay, understand. So what is, we can write the equation now. We take the circuit here, C, and let us take this as 2 microfarad. This is 2 microfarad. Okay, and this is 4 microfarad. Microfarad means into 10 raised to minus 6. Okay, now the circuit becomes like this. Now, if you can take the charge, it is capacitors charged from this side, charged from this capacitors charged from this side, and this is taken 2 times the charge for charging this capacitor. Now, we can write the equation 6 minus, we know Q is equal to CV, question we know Q is equal to CV, so we can take Q by C as voltage. Q by C as voltage. Now 6 is voltage here. Now this capacitor, because this capacitor is Q by 2. Q by 2, then if you take this is minus 2Q by 4, coming in this direction. Okay, 2Q by 4, that is equal to 0. That is, we have to find what? We have to find a charge on the capacitor C1. Here it is C1. So we have to find the capacitor charge Q C1 we have to find. But okay, here it is Q C1 by 2. Here is 2Q, we give it right here, 2Q C3 by 4. Only we are taking this as loop, applying Kirchhoff's law. Kirchhoff's law applied. Kirchhoff's law, okay. Taking the loop. Taking the loop 1, okay. We write again for convenience. We are taking the loop here. This is a capacitance, and this is 6 volt. This is a loop. Loop 1. And this is C1, this is C3. And this is 6 volt. Now we are applying the loop equation. 6 minus QC1, charge across capacitor 1 by 2, minus 2Q3. What is out Q2Q3? It is Q3. We write it is Q3. Charge across this. But Q3 is to Q1, QC1. Okay. We can write Q3 is to QC1. Okay. We write it as, if we write like this, now Q3 is to QC1. Now we can write 6 minus QC1 by 2 minus 2QC1 by QC1 by 2QC1 by 4. It is 6 minus QC1 by 2 minus 2QC1 by 4. That is 6 minus 2QC1 by 4. 2 by 2 can. Minus 2QC1 by 4. To cancel out, answer is 6 watt. 6 watt microcoulomb. Microfarad across that microcoulomb. This is a charge across the capacitor C1. This is a charge across C1, 6 microcoulomb. Okay. Capacitor in series. Then coming to, we know capacitance is in series. When two capacitors are connected in series, 2 microfarad and 4 microfarad capacitor is connected to an 80 volt source. Now, we know C is equal to Q by V, and C equivalent equal to 2 into 4 by 2 plus 4, 6, 4 by 3. 4 by 3. So charge across total charge is equal to CV equal to 4 by 3 into 80. 320 by 3. Total charge 320 by 3, and now C charge will be Q E totally equal to Q1 equal to Q2. You can see here, this is Q1, this is Q2. So now we have to find the voltage across V1, 2 microfarad or V2. To find what this, V1 is equal to Q1 by C1, Q by C1 equal to, you can say this 320 by 3 by 2. All are it by microfarad. So we can cut out. This is microcoulomb. Microcoulomb, microfarad. So micro we can cut out, giving 3.3 volt, and voltage across capacitor 2 EC1 EC2 320 by 3 by 4 320 by 12 6 volt. So this way it is distributed to get the charge across capacitor same. So voltage will be divided in series circuit. But in parallel circuits, voltage will be same. Now we take the parallel circuit. C1, C2 connected to, suppose it is connected to 80 volt, parallel. T is C1 plus C2, V is 2, 4, is 2 plus 4, 6, 6. And Q is equal to CV, charge will be what is 80 volt. Now 80 volt is 80 into 6, 480. Charge will be 480 microcoulomb. 480 microcoulomb. And this is divided into 2. Q is equal to Q1 plus Q2. Here, Q is equal to Q1 plus C2. With that we get C1 V1 plus C2 V2. Or it is C1 plus C2 into V. Common potential. So now that is 480 divided by 6 is a V equal to 80 volt. This common potential is a what? 80 volt. Now what is C1 V1? That is the charge across this. C1 is 2. Yeah. Since a parallel circuit, V1 is equal to V2, Q1 by C1 is equal to Q2 by C2. That is, Q1 is Q1 by 2 is equal to Q2 by 4. Cancel out. Q2 is 2Q1. And now we can apply what? Q is equal to Q1 plus Q2. We know Q is equal to Q1 plus Q2. That is Q2 is 2Q1. So Q1 plus 2Q1, that is 3Q1. So charge, total charge across the capacitor we know Q is equal to 18 to 6, which is 480 microcoulomb. So 480 is divided by 3 will be Q1 equal to 160 microcoulomb. And Q2 is 2Q1, which is 2 into 160, 320 microcoulomb. So we know it is double because capacitor is also, we know C1 is equal to 2, C2 is equal to 4. So it is, if C1 is across 160, charge is 160 and this charge is 320. It is 2 times, same as it is 2 times. Okay.